Welcome to our tutorial on working with parallel lines. We're going to look at these two examples, and we're going to form the equations that we could use if this were a systems of equations problem involving these angles to solve for the values of the variable. Now in class we discussed this a variety of ways. One of the first things we said was that we wanted to label the picture with the angles involved so we knew what to do. So in this case we've got angle 1, angle 5, 8, and 14 in play. And I'm going to label the same things in the picture down below because they're just the same image. I've copied and pasted it, but I've changed one of the givens each time. So in the first problem, we're given that M is parallel to N. In the picture, I want to do something to note the fact that M and N are parallel, so I'm going to highlight those in yellow. Then one at a time, I'm going to look at transversals. The first possible transversal is P. Looking at P as the transversal, and I'm going to write that out. Remember that I want to see that written on a test, a quiz, or any other assignment. Looking at P as the transversal, the two angles in play are angles 1 and 14. The question you have to answer is, are they going to be congruent, equal in measure, or are they going to be supplementary so that their measures add up to 180? Well, angles 1 and 4 would be corresponding. Given that the lines are parallel, those corresponding angles would be congruent. So it works out that 1 and 14 as angles are going to have to add up to 180 degrees, therefore they are supplementary. Now the other transversal in this problem would be Q. Looking at the two angles involved, angles 8 and 5, are they going to be congruent or supplementary? Well, 8 and 6 would be corresponding. 6 and 5 form a linear pair. So when we look at Q as the transversal, the equation that we're going to come up with is that the measure of angle 8 plus the measure of angle 5 will be 180 degrees. Now everything changes when we change which lines are parallel. So in this second example, knowing that P is parallel to Q is going to give rise to completely different equations. So now on the one hand, one of our transversals could be M. Looking at M as the transversal, our angles involved are 1 and 8. They are corresponding angles, and corresponding angles would be congruent with that transversal since the lines are parallel. So we'll say measure of angle 1 is equal to the measure of angle 8. The other transversal would be N. Looking at N, the angles involved are 5 and 14. They are alternate interior angles. And alternate interior angles are congruent when the lines are parallel. So looking at N as the transversal, we would say that the measure of angle 5 is equal to the measure of angle 14. Now if that's a little bit foggy for you, see if this makes sense. You could kind of treat each of these grids like a tic-tac-toe board. So I'm going to put an X and an O, an X and an O. But the key thing is make the vertical angles X's, make the adjacent angles different letters. And you're just going to copy that down so that corresponding angles are congruent as we go. So when you put this little grid on the picture, seeing that angle 1 is an X and angle 14 is an O, they are different symbols, so they are going to be supplementary. Versus down here, now watch the parallel lines. Corresponding angles congruent, vertical angles would be congruent with them. Other angles, I'm going to put the O on those. And now, if they have the same symbol, they would be equal. Please make sure that you do that along the parallel lines with a single transversal. One way or another, hopefully you can stay organized, color code your picture, and keep track of what the equations would be. Please each time note what the transversal is as well.